why cross multiplication works? Well, let's compare two fractions. Let's compare 3 over 6 to 2 over 4. They could be either greater than, less than, or equal to the other fraction. What we usually do is to multiply this number by this number and so on with the other fraction, and the result is going to be 12 for both sides. 2 times 6 and 3 times 4 give us 12 on both sides, so we could say that those fractions are equivalent fractions. They have the same value. This works also for addition. Let's add those fractions to 4 and 3 over 6, and we do the same. 3 times 4 is 12, and 2 times 6 is 12, and here we are going to add a new step that is going to be to multiply the denominators together. So 6 times 4 is going to give us 24, and 4 times 6 is going to give us 24. Now we can add the numerators. This is going to give us 12 plus 12 is 24, and we keep the denominator here, and 24 over 24 is going to be 1. Finally, if we want to subtract those fractions together, 3 over 6 minus 2 over 4, we do the same process. Here we cross multiply and then multiply the denominators. We are going to write the same as this. So this is going to give us 24 and 24. And here we are going to subtract 12 by 12, and this is equal to 0. And we keep the same denominator, and this would be 0. 0 parts of 24 parts. So let's decrease the size of this so we can keep the answer here. And why does it work? Well, let's see it this way. If we have 6 over 6, we can say that this is a unit. First, we are going to represent this with a square, or well, a rectangle, and we are going to have this unit divided how many times? The 6 times. The denominator is going to tell us how many times we need to divide this unit, this whole. Now we have our 6 parts. How many of those parts we have? We have all of those parts, 6 over 6. And this could be also be represented as 1, a unit. We could do that also for the number 4. If we have 4 fourths, we are going to represent this by a square, and we are going to divide this how many times? 4 times. And how many parts of those we have? We have 4 parts. We have all the parts for that unit, which means we have 1. This is equal to 1. So what happens if you want to add, for example, 1 part of this fraction plus 1 part of the other fraction? We would do 1 plus 1 equals 2, and 4 plus 6 equals 10. and this is wrong. Why? Because this one right here is not, it doesn't have the same value as this one right here. This one is bigger, slightly bigger than this one right here, and being that said, it doesn't make sense to sum them up. We could do 1 plus 1 equals 2 if they have the same value, if they are equal. But in this case, this one right here is slightly bigger. It's like if we were summing a bigger one plus a tiny one, and let's say this is the real value of 1, so we would have like 2 point something. So that's why it's not possible to sum them up here, a numerator plus another numerator. They don't have the same value. And the same happens to the denominators. They are not the same value. This fourth is, or those 4/4 are greater than these fractions right here. So what we need to do is to have the same numerator, so we are summing the same amount, let's say. So let me shrink it down this 1 second here a little. For example, we have 1/4, and we are going to sum that to another 1/4. Now we are talking about the same proportion. This one is equivalent to this one. They have the same value. They are proportional. It's like having this one. This is a unit divided into 4 parts, and we could have this one right here, this one right here, and sum them up. They are the same value. And if we sum those up, we are going to get 1 plus 1, 2, and the denominator remains the same because we are not adding the numerator twice, let's say. And as we can see here, is giving us 2 parts of those fourths. We can see visually here. So let me shrink this a little. And here on the left, we are going to make those problems with this into account. So if we have 3/6 and we want to compare that to 2/4, what we're going to do is to try to get the same denominator, so our whole and our division would be the same for both fractions. If we don't have the same numerator, this 3 is going to be different in value than this 2 right here. So how we do that? An easy way, there are many ways, but the easiest will be to multiply the denominators. So 6 times 4, or we could do, usually people do that like this. 6 times 4 is going to be 24, and we do the same with this other fraction, 4 times 6, and we do that for both numbers. So we multiply also here by 4 and by 6. Why? Because if we increased this number right here by 4, we would have to do the same for this one. It is like having Let's take the 4 here. It's like increasing this twice. The whole fraction increased, I mean this number here below, and also the fraction itself increased as well proportionally. So that's why we need to multiply both by the same number. So here this would give us 4 times 3. Let's type this here. It will give us 12 over 6 times 4, which is going to be 24. Let's move this a little bit to the left. Let's separate them. Yeah. 2 times 6, this is going to be equal to 12, and 6 or 4 times 6 is going to give us 24. So we have 20, this fraction here, this fraction here. We can see now that they are equal, they are equivalent fractions. Again, the same, for addition. Let's do the addition. Let's shrink this a little here. So we follow the same process. We have 3 over 6 plus 2 over 4. If we multiply the numerators, we are going to get 24 on the bottom, and the numerators we are going to multiply. This was multiplied by 4, so we multiply this by the same amount, which is going to give us 12. And again, the same with the number 2. We already multiplied 4 by 6, and now we need to multiply 2 by 6, which is going to give us 12. And this is going to give us 24, and we get the same answer as the one in the beginning. So that's it. That's why we cross multiply, and that's why it works. Thank you.